I noticed an intelligent design feature in our solar system. The planetary days to complete one revolution around our Sun. Let me explain what I noticed. Let's start by looking at the number of days in an Earth year. As we all know, there are 365.25 days in each Earth year. And what constitutes a day? 24 hours. Right? Actually, not exactly. With a little research, you will find that a day on Earth is not a full 24 hours. It is actually only 23 hours and 55 minutes per day. How do we know this? I'll explain. With observation, it can be seen that the stars return to the same position above the horizon, about 5 minutes later upon every evening. This constitutes a full revolution of the Earth. It is hard to measure a day by the rising and setting of the Sun. This because the hours and minutes of daylight changes every day, except for those that live on or near the equator. A day based on the Sun is a solar day. A day based on the stars is a stellar day. A solar day upon the Earth is 23 hours and 55 minutes per day. A stellar day is a full 24 hours. Our clocks, however, are synchronized to a solar day, 23 hours and 55 minutes. With calibration, the 23 hours and 55 minutes are made into 24 hours on our clocks. This may be hard to understand. I would suggest then that more research be done on this anomaly. A stellar year is only 364 days, constituted by a stellar day that is a complete 24 hours. A solar year is 365.25 days, and is constituted by a true 23-hour and 55-minute day. I will explain how they are related. The difference is 5 minutes. 5 minutes multiplied by 364 stellar days is 1,820 minutes per year. 1,820 minutes divided by 60 minutes per hour equals 30.33 hours, or 1.26 days. The difference between the stellar calendar and the solar calendar is about 1.26 days. This is due to the loss of 5 minutes per day from the 364 stellar days in a year, each with a true 24 hours per day. Because the solar days are short, almost 5 minutes per day, it takes an extra 1.25 days for the solar calendar to match the stellar calendar. With this argument, I would like to say that there is only 364 days of 24 hours in a true Earth year, as measured by stellar time. For the purpose of this video, let's say the Earth has 364 days in a year, like ancient calendars also had. With a little research, you can learn about the 28 mansions of the Moon. Our Moon. This represents 28 positions that the Moon sets, in comparison to the stars of the ecliptic. 28 different positions. These are the 28 houses, or mansions of the Moon. Every major culture on Earth has a version of the 28 Moon mansions. Now let's use a simple equation with both of these numbers, 28 and 364. Let's divide 28 into 364. 364 days divided by 28 Moon mansions equals 13 days per Moon mansion. So, 364 days in an Earth year divided by the 28 mansions of the Moon equals 13 days per Moon mansion division. This is using a stellar calendar with the Moon mansions that are also based on the stars. They are stellar Moon mansions. Now let's use the number 28 as a denominator number to suggest an intelligent design in our solar system. Now let's look at the number of days in a year on Venus. Venus spins around less than once during its solar revolution. In other words, it takes more than a Venus year for Venus to complete one day. For this reason, Venus days, to complete one full revolution around the Sun, have to be measured in Earth days. Earth stellar days. With some research, the Internet will tell you that Venus has 225 Earth days in one solar stellar year. With further research, you can calculate that this is only 224 stellar days of a full 24 hours. So, staying with the concept of stellar days, let's say Venus has 224 stellar days in one solar year. Now let's do a simple equation again with our denominator, 28. Let's divide 28 into 224 days on Venus. 224 Venus days divided by 28 design number equals 8 days per moon mansion. Keep in mind that a moon mansion is a set of stars that appear in the ecliptic. The ecliptic is the same for all of the planets in our solar system, except Pluto. So, the equation equaling 8 days per moon mansion of the ecliptic for Venus, and 13 days per mansion for Earth. Keep in mind that a moon mansion is a set of stars in the ecliptic, rather the moon is in the mansion, or not. It is the ecliptic constellation stars, divided into 28 separate divisions, as per our perspective of their relationship with our moon. Venus passes by one mansion of the ecliptic stars every 8 days. The Earth passes by one mansion of the ecliptic stars every 13 days. The common denominator being 28. The 28 mansions of the ecliptic stars. Now let's look at the number of days in the year on Mercury. The number of days on Mercury, to complete one solar year, is 88 Earth days. Using the same equation, with our denominator number, 28, we can divide 28 into 88 days. 88 Mercury days in a year, divided by 28 ecliptic constellation star divisions, equals 3.14 days. 3.14 also being the number for pi, when using the pi equation for circumference of a circle, based on its diameter. So, there are 3.14 days, or a pi number of days, in each of the 28 constellation star divisions of the ecliptic. 28, appearing to be a design number, when it comes to the equation of the number of days, in each planet's solar year. In another video, I demonstrated how 28 fits into a pattern, with the numbers from 1 to 1000. Counting by ones, 1 through 10, is 10 different values. Then, counting by tens, 20 through 90, is 8 different values. Then, counting by 100s, 100 through 900, and then also 1000, is 10 different values. The total number of different values then being 28. 28 different values, from 1 to 1000. The Paleopictograph alphabet, the first real alphabet of the world, I believe is also 28 pictographs. I talk about this alphabet in detail on another one of my videos. Pictographs from this original alphabet can be found in all major root languages and alphabets. The pictographs of the sounds of the letters could also be exchanged to represent the 28 values, 1 through 1000. The 28 pictographs, their sounds, and their values, could also be assigned to the 28 mansions of the moon. This, I believe, also shows intelligent design, using the number 28 as a prime design number. Now let's look at the number of days in a year on Mars. Mars has nights and days that are very similar to those on the Earth. For this reason, we can use the Martian days, as well as Earth days, to calculate a solar year on Mars. A Martian year is 687 solar Earth days, or 685 stellar Earth days. A Martian day, however, is between 37 minutes and 42 minutes longer than an Earth day. 37 minutes longer than a stellar Earth day, and up to 42 minutes longer than a solar Earth day. For this reason, there is only about 671 Martian days in one Martian solar year. Using the number 28 again, we can divide 671 Martian days by 28 divisions of the ecliptic constellation stars. 371 days divided by 28 divisions equals 23.96 days per division. So, it is about 24 Martian days per division of the 28 ecliptic star divisions. Now, let's look at the number of days in a year on Jupiter. The orbit of Jupiter around the Sun takes about 12 years. 1 year for every full constellation of the ecliptic stars. For Jupiter, the intelligent design is just that simple. It is the first to be measured in years, rather than days, upon the Earth. Jupiter averaging one of the 12 ecliptic constellations every year, as it completes a 12-year cycle around the Sun. Now, let's look at the number of Earth years in a year on Saturn. The orbit of Saturn around the Sun takes about 29.5 years on Earth. 29.5 Earth years is equal to only one solar year on Saturn. 29.5 also being the number of days in moon cycle around the Earth, a lunar cycle. So, the number of Earth years in one Saturn year is the same as the number of days in an Earth lunar cycle. I believe this is also an intelligent design feature. Now, let's look at the number of Earth years in one solar year on Uranus. One solar year on Uranus is about 84 Earth years long. 84 Earth years divided by 28 ecliptic constellation star divisions equals 3 Earth years per ecliptic star division. So, it takes 3 Earth years for Uranus to pass through one of the 28 mansions of the Moon. Also, if we divide 84 years by 12 for the 12 ecliptic constellations, it equals 7 years to pass through one constellation. I believe this is also an intelligent design feature for Uranus. Now, let's look at the number of years for 1 year on Neptune. Neptune takes 168 stellar years to complete all of its cycles. To complete a cycle through the constellations and around the Sun. Also, to complete alignments with Jupiter and Uranus. The cycle for Neptune, of 168 years, is exactly double of the 84-year cycle for Uranus. This means that with the equation, using the denominator number 28, the answers will come out exactly double of the years for Uranus. 168 years divided by 28 equals 6 years per moon mansion of the ecliptic constellation stars. Then also, 168 years divided by the 12 constellations equals 14 years per ecliptic constellation. I believe this to also be evidence of intelligent design. This is exactly double the exact values of Uranus. Now, let's look at the number of years for 1 year on Pluto. It's debatable if Pluto is even a planet. It does not have the same orbit nor the same ecliptic stars as the other planets in our solar system. Let's look at the year cycle of Pluto anyway, to see if there is any evidence of intelligent design also. The estimate of years for one solar year for Pluto is between 248 and 250 years. This is only an estimate, because we only discovered Pluto 90 years ago, in 1930. For this reason, we have only witnessed a third of the solar cycle of Pluto round the Sun, and through the stars. 248 to 250 years is only an estimate of the number of years in one solar and stellar cycle of Pluto. Using the pattern of intelligent design in our solar system, I would estimate that the number of years in 1 year on Pluto is actually 252 years long. This is exactly 3 times the number of years for 1 year on Uranus, and exactly the same as the number of years for Uranus and Neptune both combined together. This meaning that if we use the equation with the denominator number of 28, the values will be 3 times those for Uranus, on Pluto. 252 years, divided by 28 stellar divisions, equals 9 years per ecliptic star division. That's 3 years per division of 28 for Uranus, 6 years per division for Neptune, and 9 years per division for Pluto. Here we can see the configuration of 3, 6, and 9. Also, if we divide 252 years by 12 constellations, we get 21 years per ecliptic star constellation. That's 7 years per constellation for Uranus, 14 years per constellation for Neptune, and 21 years per constellation for Pluto. I believe this also illustrates intelligent design in our solar system, with Pluto. As you may know, the Sun is 400 times larger than the Moon, and 400 times further away from Earth than the Moon also. The Moon then is 400 times smaller than the Sun, and 400 times closer to Earth than the Sun is. Because of this intelligent design, we get the perfect appearance of the eclipse of the Sun by the Moon, a solar eclipse. Even the Moon phases are perfect, and also appear to be of intelligent design. Thanks for watching. Please subscribe to the channel. Check out the book series, The 24 Elders in a Little Scroll. Here is the link. This link, and additional links, are posted in the video description. Thanks again.